Hello everyone, and welcome to another one of our AI and machine learning deep dives. Today, we are diving headfirst into two of the absolute titans in a data scientist's toolkit.
We're going to jump right in. Let's get to it. So you've definitely seen these names pop up everywhere, from winning Kaggle competitions to powering major enterprise solutions. But let me ask you a question. When you really get down to it, what's the actual difference between a gradient boosting machine and extreme gradient boosting? Well, that's exactly where we're going to unpack right now.
But before we can talk about what makes them different, we have to talk about what makes them so similar. You see, both of these algorithms are part of this really revolutionary idea in machine learning called boosting. And it all starts with this core concept, ensemble learning. The idea is, instead of trying to build one single, flawless model, you combine a whole bunch of simpler, weaker models. The jury analogy is perfect, right? Any one juror might miss something. But when you put all 12 of them together, you get a much more reliable, much more accurate decision. Now, boosting takes that jury idea and puts it in a sequence. So imagine you build your first simple model. It does okay, but of course, it makes some mistakes. Well, the next model you build has one job and one job only, to fix the errors that the first one made. Then you build a third model to fix the mistakes of the second one, and on and on. It's like building a team of specialists where each one gets smarter by learning from the one before it. Okay, so with that basic idea of boosting in our heads, let's talk about the original powerhouse, the gradient boosting machine, or GBM. This is really the algorithm that laid the groundwork for everything that came after. So GBM is the classic textbook implementation of this whole boosting concept. It builds a chain of decision trees, one after another. And each new tree is specifically trained to predict the errors, or what data scientists call residuals, of the entire team of trees that came before it. It is just relentlessly chasing down and correcting its own mistakes. Now, you might see some formulas on the screen, but don't get hung up on the math. The real magic, the core idea, is super simple. The algorithm builds a model, finds the errors, and then the next model it builds tries to predict those errors. So the new models aren't learning from the original data, they're learning from the mistakes of the previous models. That's the engine of GBM right there.
So if GBM was the solid foundation, let's talk about the algorithm that took that same idea and basically strapped a rocket engine to it, XGBoost.
Now, XGBoost, or extreme gradient boosting, isn't a totally new thing. It's an implementation of gradient boosting. Think of it as being built on the shoulders of GBM, but it was re-engineered from the ground up for pure performance and accuracy. It's packed with a ton of powerful upgrades.
This quote really hits the nail on the head. The people behind XGBoost didn't try to reinvent the wheel. They just took the brilliant idea of gradient boosting and souped it up in almost every way imaginable. So, let's break down what those enhancements actually are.
So what exactly puts the extreme in XGBoost? Well, let me walk you through the 4 key upgrades that have really made it such a dominant force in machine learning.
Okay, the first and probably most famous upgrade is just raw speed. While the overall boosting process has to be sequential, one tree after another, XGBoost is incredibly clever. It parallelizes the steps inside of building each tree. It uses all of your computer's power to find the best way to build that tree, all at once. For big data sets, this is a game changer. And that brings us to takeaway number 1. XGBoost is faster due to parallel processing.
Next up, let's talk about building smarter, more robust models. See, any powerful algorithm runs the risk of overfitting. That's where it basically just memorizes the training data instead of learning the real patterns. XGBoost has this amazing defense against that called regularization. You can think of it like a penalty for making the model too complex. It constantly asks, is adding this extra detail really helping that much? This helps the model generalize way better to new unseen data. And that brings us to takeaway number 2. XGBoost has better regularization to fight overfitting.
All right, this next one is a little bit more about the math under the hood, but it's super cool. Think about finding the fastest way down a hill. GBM uses what's called the gradient. It's like knowing the slope of the hill, which tells you which way is down. But XGBoost uses something called the Hessian. This gives it information about both the slope and the curve of the hill. It knows not just which way is down, but how steep the path is. It's a much more direct route to the bottom. So that brings us to takeaway number 3. XGBoost uses more advanced math for better optimization.
And finally, it's not just about the raw power. XGBoost is just packed with features that make a data scientist's life easier. It can handle missing values in your data automatically. It has a much smarter way of trimming its decision trees. It's even got cross-validation built right in. These are just massive time savers in the real world. So that brings us to takeaway number 4. XGBoost includes user-friendly features that just simplify your whole workflow.
All right, we have covered a ton of ground. So let's just do a really quick final recap to make sure we've got the key differences between these two algorithms locked in.
So let's run through them one last time. Takeaway number 1, XGBoost is built for speed thanks to that parallel processing. Takeaway number 2, its advanced regularization makes it way better at fighting overfitting. Takeaway 3, its optimization engine is just smarter, using more advanced math to find the best answer faster. And finally, takeaway number 4, its usability is just fantastic with all those built-in features that save us a ton of time.
So yeah, XGBoost is clearly this high-performance, feature-packed evolution of GBM. But that leaves us with one final thought, something for you to consider. While XGBoost is usually the go-to choice these days, are there times when the raw simplicity of a standard GBM is actually all you need, or maybe even better? Knowing the real difference is what helps you pick the right tool for the right job. That's all for now, folks. Please like, share, and subscribe for more like this.